So presenting is Noemi Bala, CTO of Aortyx.
Good evening, everyone. I'm Noemi Bala, CTO and co-founder of Aortyx, a company that is dedicated to create a new way to treat aortic diseases. Everybody knows Albert Einstein. He developed the theory of relativity. But what most of people don't know is that he died from an aortic disease. Aortic diseases have been historically undertreated by medical devices companies. An aortic dissection is one of the most complex and catastrophic events that can occur in the aorta. And what is aortic dissection? This disease starts with the formation of a tear in the aortic wall. This tear allows blood flow in the aortic wall and forces the separation of the layers of the aorta, creating what is called false lumen. The incidence of this disease is not too high, but the problem is that up to 50% of the patients die from this condition. We have estimated a worldwide market of $450 million, and here you have the distribution. 60% of the market is only in the USA. And what are the existing treatments nowadays? Basically, there are two ways of treating aortic dissections, open repair or endovascular repair. Open repair is a definitive solution in which the affected part is replaced by a synthetic vascular prosthesis, but this is a highly invasive procedure in which it entails high mortality rates and long hospitalization times. Endovascular repair reduces both mortality and hospitalization times, but it also implies complications. There is a mechanical mismatch between the graft and the vessel, and this causes failure. And hence, there is a high rate of reintervention rates. What we create? At Aortyx, we aim to change the paradigm in treating aortic dissections. We believe that a biodegradable adhesive device, which mimics the biomechanical environment of the aorta, is the best solution that can change our patient's life. We developed a device with a biodegradable polymer that sticks to the aorta using a biocompatible glue and which is decorated with regenerative molecules. We have proof in an ex vivo test that the patch adheres to the aorta and resists flow. And also in an in vitro test, we have shown that cells are able to climb on top of the patch and start colonizing it. Our team, the other founders apart from me, Jordi Martorell, who is the CEO of Aortyx, Vicent Riambau, who is the CMO and a world-known vascular surgeon, and Salvador Burros, who is the CSO and a key opinion leader in material science. We are now raising in a seed fund to prove our technology in vivo, to industrialize our technology, and also to expand our IP and so. And I just want to ask you a question. Are we willing to keep losing geniuses? Thank you.
Thanks, very nice speech. So again, it's time for questions.
Hi. How much have you raised until now?
Good question. We present the round on the 14th of February, and we pretend to raise 300,000 euros, but we have raised nearly 500,000 till today in the round. But before this, we have entered in the Cash Impulse program that I think it was 77,000. And also, we have been founded by FIPSE and by Jabot from La Generalitat. In total, I think that 120,000 in total till today, plus the seed round that we are now raising.
You close or you are raising?
We are raising.
Okay.
But we haven't closed it yet.
Thank you.
I have two questions, but I only allowed to make one. More a technical one then. Your intervention is once the dissection has occurred.
Yes.
It's not because the main problem of this disease is diagnosed.
I know. Yes.
So, what is the differentiality? I mean, it's the non-invasiveness of the procedure that really makes a stop on the bleeding part of the aorta. Is that the case?
The thing is that it's not invasive as the endovascular repair that exists today. And the second thing is that with the existing treatments, they put a graft in a very long part of the aorta. But we only focus on the local part where is the tear, and we only face that point, so we can start the regeneration on that point and not affect the other parts of the aorta. That is the key point. The problem is that it's difficult to diagnose, but when it's diagnosed, I think that our solution would be much better than the existing ones.
But this relies on the assumption that the tear doesn't grow.
Yes. Mechanically, but the thing is that our patch is viscoelastic, so it can contract and expand with the hard poles. So we believe that the tear will not grow anymore when our device is placed.
Sorry, I think that they have made something. Is there any patent involved with your project?
Yes, we have filed a patent application that will end in this 13th of March. And we are now discussing with our advisors and our lawyers that we have to prove our technology, and we are now running. We are doing now a lot of proofs these days to finish with this.
So this is an endovascular patch.
Yes.
It goes inside the lumen.
Yes.
And
inside the aorta.
Inside, in the inside.
Yes,
It
yes.
doesn't go in the outside. So you've shown lots of pictures about the aortic arch.
Yes.
Is this the area it will be the most useful in?
No.
Or so
No.
what's the reason for that?
I have shown this. The
Yeah.
aortic arch is this, and
Right. So is
this.
it for thoracic or for abdominal?
We
aorta?
aim to we believe that our patch would go to every part of the aorta, but we will start with the thoracic aorta because it's an easier part and because it's easier to get there.
Right. And this condition tends to, it does not always, but it tends to happen in aged individuals with suffered vasculature, which also comes with elements of vascular calcification and atherosclerosis. How will this patch deal with that?
Well, I think in the same way. Well, it's different that the grafts that are existing now because they compress the aorta, they expand the aorta. But I think that it wouldn't be a problem because it's easier. The procedure is easier, so they will be able to reach out the surgery. I don't exactly know how we can manage the arteriosclerosis because maybe they can be medically treatment before they are interviewed.
Thank you.